Welcome back. We're going to have a look at more annuities due now. We're just going to carry on the work we've done, much like we did with the previous section with ordinary annuities. But now we want to look at how do we calculate payment, how do we calculate I, and how do we calculate the interest rate, small I, if the payments are at the beginning of each period. So let's get started. Can we go ahead and do a similar thing with payments? Well, if you remember, for payments, we had two versions of our formula when we did ordinary annuities, one for FV and one for PV. Well, we have the same thing now. It's just where does that little 1 plus I end up? Well, here they are. If you know the future value due, it's payment is equal to future value due over the old annuity part here and the 1 plus I. If instead you're starting with present value due, there's the annuity piece. There's a 1 plus I. Those are all down in the denominator. You may find an extra set of brackets is helpful if you try to type it in all in one kind of go in your calculator, or you can do all the denominators, store that, and then divide it into future value due, whichever way you prefer. But you want to make sure you kind of keep the denominator intact. All right, let's have a look at a couple of these. Mr. Walters already has some money in his RRSP. His goal is to build it to be even greater, $250,000. And he's going to put in contributions every 6 months over the next 7 years. So he's got 14 contributions to build it up. What should those deposits be if he can earn 8.5% on his money? Well, let's draw a quick timeline here. We've got 7 years to go, or 14 periods. He's going to put some money in at the beginning of every 6 months. So that's an annuity due. There's 14 of those deposits going in. Little I is 0.0425. So that's sort of the basic setup. He wants his goal to be 250,000. So I'll put that down there at the end. That's at 7 years. Oh, but wait, he's already got 104,000. Does that mean that he only has to save the difference? Let's see, 250 minus 104 would be 146. So that would be what we'd use for the goal? Almost, but not quite. If you did that, you forgot about the time value of money for the 104,000. If I'm making this my focal date down here, the 104 is actually going to keep earning interest, isn't it? There's no reason why the money he's already got in the bank shouldn't earn interest as well. So really, my $250,000 goal is going to be taken care of by the 104 that he's already got, carried forward, plus all of those payments. Does that make sense? So the payments really have to add up to the 250,000 minus the 104 with interest. So our goal then for the payments the 250 minus the 104 with interest, and that's well, let's write it out here. The 104 with interest. So if I take the difference there, I end up with $63,749 and 16 cents. That's all that would be remaining for him to save. The 104 actually grows by a lot and becomes quite large, so there's only a little bit left over that he's going to have to make up with his contributions. So that 63,749 is what I'm going to use now for my goal, for my future value due. So let's go to the payment formula. Put 63,749.16 divided by 1 plus I minus 1 over I times 1 plus I. Plug that in our calculator. And we come up with $3,286.10 every 6 months. We always got to remember what the periods are, don't we? So he's going to have to put in about $3,200 every 6 months, a little more than $500 a month. And he'll be all right when he gets to retirement. He'll have a full $250,000. Let me give you one to try out. In this case, we've got a company, and they sell remote sensing equipment for fish boats. Their Fisheye 2000 product sells for $89.50. They want to give their customers the option of 24 monthly payments. The first payment's due today. So really they're setting up a lease for their customers because the $89.50 might be a little bit too much for a lot of people to pick up. But if they break it down into monthly payments, well, we could probably do that okay. Question is, how much should those payments be? Well, using a rate of 6%, see if you can work that out. Go ahead and hit pause, and I'll come back in just a minute when you're ready to help you out. All right, let's have a look. The first question with these when we're doing payment always is that big number present or future value? Well, in this case, it's present value because that's how much it's worth at the beginning. If we bought it today, that's what we'd pay. We said the first payment was due today, so I went ahead and wrote the word due there as well, just to remind me. I've got a rate of 0.005, and I've got an N of 24 in this one. I want to work out the payment. Is our question. We'll go ahead and put the numbers in here. $89.50. 1 minus 1.005 to the negative 24.005 times 1.005. And if I go ahead and work that through, I get $394.70. That's how much it would be per month. Probably a lot more affordable for the people buying the equipment. Now, what happens if you didn't quite get that? Let's not just carry on too quickly. Let's stop for a minute. If you worked all this out and you had the same formula that I had, but you didn't get the same number, you got a number a little bit bigger. What that means is a 1.005 accidentally migrated up top for you. You know, what you did, you went 89.50 divided by everything in square brackets, and then you went times 1.005. Well, that's actually, you're going to move the 1.005 to the top. How do you keep it on the bottom? That's what I was mentioning earlier. You go ahead and you put brackets around the entire denominator, and then you can keep it down below. So if you didn't quite get the right number, but you're close, go ahead and try it again with an extra set of brackets. Or just work out the denominator and use your store button, put it into memory, and then bring it back later. Or if this makes any sense to you, if you're a little more mathy, mathematically inclined, work out the denominator and then press the 1 over x button and then multiply. That'll take the reciprocal and let you multiply. A couple different ways you can do it. Keep practicing until you can get the right answer. And if you're struggling at all with your calculator, give me a shout and I'll try and help you out with that as well. All right. Let's move on to our next little section then. We're kind of going through these quickly, but we can because we're used to this pattern: future value, present value, payments, solving for n. Well, that's what we want to do next, is solve for n. So just like we've done in the past, I'm going to solve for n for an annuity due. Here's the two versions of the formula. Where did the 1 plus I end up? Right beside the payment. All right. So it looks a little, a little more intimidating perhaps, this formula, but really it's not too bad. Once you get numbers in there, you'll see. But that's it's very similar to the one we used before, but because it's due, there's a 1 plus I in there. All right. Let's go ahead and have a look. An investment fund is worth $210,000, so that must be today, and it earns 9% compounded monthly. If we start taking out withdrawals of $2,000 at the beginning of each month, right away, how long until we run out of money? That's a real common question, isn't it? A lot of people get to retirement, they've got some savings. They want to know how long it's going to last if they take a certain amount out. So that's one we can work on. Well, I've got a present value due of $210,000, a payment of $2,000, and an interest rate of 0.0075. That's the 9 divided by 12, isn't it? I want to figure out how long it'll take. Let's just stop for a minute and think sort of big picture here, ballpark it. If I was not earning any interest at all, and I took $2,000 a month out, $210,000 would last exactly 105 months, wouldn't it? Because I'm earning interest, it's going to last longer. So I know I'm looking for a number bigger than 105,000. So that gives me a bit of an idea, of what I'm aiming for. But it's probably going to be a little bit bigger, isn't it? Maybe even a good chunk bigger because I'm earning 9%. So let me work this one through and we'll see what we get. And in this case, we're going to use the negative log formula. 1 minus I times PV due over the payment times 1 plus I divided by the log of 1 plus I. I plug all those in there and I get 203.64. The question now, 203.64 what? I know it's time, but what time frame am I dealing with? I'm withdrawing money every month. So this must be or this must come out in months then, isn't it? So that's the inputs I used. 203 months. Actually a good chunk longer than the 105 that we talked about earlier. That's great. Now you may find though in real life that's not quite good enough for an answer, because if you said that to the average person on the street, they would not know how long 203 months is. So I could divide by 12 if I wanted and end up with an answer in years, and that works out to be 16.97 years. So that's how long the person can enjoy some retirement funds. Let's keep going. If you want to try out, how long will it take to save a $20,000 down payment for a house? If you save $500 per month starting today, that's a great question, right? When you're first starting out, you decide you want a home, you're going to save up the down payment. How long will it take? Well, let's assume you can earn 6% on your money. If you're putting in $500 a month starting right away, how long will it take to get to $20,000? Like always, I'm going to recommend you press pause right now, try it out, and when you're ready, come on back and check your answer with me. All right, let's have a look. We want to have $20,000 in the future. We're going to save $500 a month all the way along until we get there. We don't know how long it's going to take though. That's our question. But we know that the interest rate is 0.005. Well, let's have a look. That would mean that the future value due is 20,000. We can see that the 20,000 is down there in the future. So let's go ahead and use the other formula for n, the log of 1 plus I times the future value due over the payment, over the payment of 500 times 1 plus I. And then divide all that by the log of 1 plus I. Hopefully you started out with that, and if we got it into the calculator correctly, get 36.39. And again, what kind of periods are we talking about here? Well, we were working in months, weren't we? So the answer is going to be in months as well. That might be good enough. Or you could again divide by 12 and get 3 years. Just over 3 years actually, 3.03. Good point for you to think about now as you're going through the book. Often they'll round it up to the next payment, the next period, because they're thinking, well, you have to work only in payments. So instead of 36.39, we'd say 37 months, knowing that the final deposit would be much smaller than 500. That's okay, and that's realistic. I'm going to keep it simpler for you than that, though, on exams. I'm just going to say, give it to me to 2 decimals. Don't worry about the fact that we have to just round to the next payment. All right, so let's just keep it a little bit easier. But if you go through the textbook, beware, they sometimes do that. And so if your answer is a little bit different, you'll know what's going on. All right, let's keep going. All right, let's have a look at solving for the interest rate now. Just like before, there's no formula for small I that we can deal with. So instead, we're going to have to use our calculator and use the built-in functions to calculate interest per year. Now, how does the calculator know that we're dealing with an annuity due or that the payments are at the beginning of each year? Well, it has something called begin mode, BGN mode, to do that. And you see I've circled the payment key over here on our calculator, and it's right in behind that. So if you press second payment, you'll be into a little work screen where you can choose beginning or end mode. Those are the 2 choices. So if you go ahead and try it on your calculator, press second, and then press BGN. And then your display will say either end or BGN. End is for ordinary annuities like we've already been using in past chapters. BGN is for annuities due. To get it to switch between the 2, all you have to do is use the set key. So you go second and then set. That's right at the very top left area, isn't it? Right behind the enter key. You press second set, it'll flip from whatever it had in the screen to the other choice. So if it said end, it'll now say BGN. If it said BGN, it'll now say end. So you can flip back and forth or toggle between them using the second set key. And it's just that easy. Once you put it in begin mode, it'll show a little BGN in the upper right hand area of your screen just to remind you, and that'll stay there. And so our key thing, of course, when we're doing lots of problems, especially on an exam, make sure you check and you have it set in the right mode for the particular annuity that you're dealing with. So it's just that easy. And once we've got that, we can just go ahead and solve for I or anything else. All right, let's have a look at an example. Got a lease agreement valued at $7,500, requires payments of $450 at the beginning of every quarter for 5 years. What's the nominal rate of interest charged? And I want it as a quarterly compounded rate at J4. All right, so it's a lease agreement. That tells me that it's at the beginning of each period. Leases are, so we're going to put the calculator in begin mode. I want my answer to come out as a quarterly compounded rate, so I'm going to set CY to 4. I'm making payments at the beginning of every quarter, so I'm going to set PY to 4 as well. All right, so that's all in there. N will become 20, won't it? Because I'm doing 5 years of quarterly payments, so N will be 20. 7,500 is the value of the lease agreement. That must be today, so that's the present value. And we're going to get something worth $7,500. We're going to make payments of $450, so again, I'll make that negative because it's a cash flow out, isn't it? We don't want to owe any money at the end, so it doesn't say anything about that, so we better get it down to 0, so that's fine. If I then go compute the interest rate, I end up with 8.03%, or in other words, J4 is equal to 8.03%. Right? Remember, the IY is always the nominal, so 8.03%. That's it. It's just that easy. There is no formula for this, but our calculators are great at doing this. So we can just plug in our numbers and get the answer straight up. Now, could we do something more fun with it? What if there was some residual money, a residual payout at the end? You know, they said, oh, you're going to have a $500 payment at the end to contend with as well. That sometimes happens with leases. The lease will let you pay off most of the money, but not all of it. And you still have to make one final big payment at the end if you want to keep the thing. All right. Could we deal with that? Sure. We would have taken that 500 and put it in there as our future value, but let's think for a minute, positive or negative? Well, residual means you still have to pay it, so we would make it negative. All right. And that would let us handle that slightly more complicated lease situation that you may see from time to time, and you see some of those in the practice problems as well. We can also have a general annuity due, and that's a case where the interest rate that they give us doesn't match the frequency of our payments. So we call that a general annuity due, and to solve that we're going to do very much the same thing we've done for other general annuities. We're going to convert the interest rate first and then solve the resulting simple annuity due that we end up with, and we're going to use our formula for I2 that we've learned previously. Or if you're doing things on your calculator, you can simply set PY and CY differently as appropriate, and things will work out just fine as well. Jasper's going to invest $200 at the beginning of, so that's an annuity due, every month, so we're dealing with monthly payments, into his RRSP. If he can earn 7% compounded quarterly, what will his investment be worth in 25 years? So the rate's quarterly, the payments are monthly, and they're due. Can you go ahead and solve this one? Well, I'll give you a minute to work on it, and when you're ready, press play, and I'll go through it with you. All right, let's have a look. So we have a payment of $200 per month. 25 years of monthly payments would give us $300 altogether. And the rate per period is going to be 1 plus the 0.07 over 4, switching from quarterly to monthly, minus 1. And that works out to be 0.005799633. Want to keep all the decimals there, and we want to work out the future value of this whole thing, and it's future value due, isn't it, in this case? Let's go ahead and plug that into our formula. The future value due is going to be 200 times 1 plus P. No need to rewrite it if we've got it written down once already, to the power of 300 minus 1 over P times 1 plus P. Plug all that in there, and I'm hoping you came up with $161,914.71. That's the future value due for a general annuity due. Could you use the calculator buttons instead? Of course, just like we just learned. If you'd rather, you could go in, make sure you're in begin mode. Payments per year, that's 12, and the compounding per year, that's 4. So we'll set those things up. That's kind of our basic setup. Then you could go ahead and put in 300, press N. Let's see, the next key along, we'll go ahead and put in the interest rate of 7% per year. Then we'll go and put in our present value of 0. Let's move along here. We don't, or we do know the payments, so we're going to put those in as well. That's negative 200. That'll go in for payment. And then we'll go compute future value. Because we're in begin mode, it'll be the future value due, and you should come back with the same number. The interest rate conversion was taken care of already because you had changed and made CY different than PY. So the calculator already knows time to convert everything. Let's go. That's really it for annuities due. Well, that's it for annuities due. Here's a quick recap of the formulas. In yellow here on the left, I've got the formulas when we know the future value due or when we want to calculate future value due. That's a large amount of money. There's one for FE due, one for payment, and one for N. There is no formula for I, but we can use our calculator for that. In the green, we have the similar formulas, but the other set, right? The set where the big amount of money is in the present. So we have a present value due, payment, and an N when we know present value due. So that's kind of the big question, isn't it? Where's that large amount of money at the beginning or at the end? I recommend a timeline, like always, to get sorted out. And then, of course, anything in this section, payments at the beginning of, payments starting right away. That's the type of terminology you would look for. Another common one, of course, leases, right? Lease payments, rental payments are always due at the beginning. All right, so that's it for now. Good luck with the material.